In this video, I'll briefly discuss continuity with respect to both curves as well as surfaces. And if you're used to solid modeling, you probably haven't dealt much with curvature continuity, or if you've just been using the solid modeling tools. And in surfacing, curvature continuity is going to become very important to produce good-looking surfaces. So I won't go, as I said, I won't go into too much detail on continuity. I just want to come at this from a standpoint of what's going to produce a good-looking surface, as that's going to be the main goal in surface modeling. So if I take a look at this sketch, I can see 5 different curves here, or 5 different sets of curves. And typically in SolidWorks you'll be dealing with 3 types of continuity. C0, which is simply contact continuous. So if we look at this closely, we can see that these contact, but there's no tangency or radius matching between the two. The next is C1, which is tangent continuous. And if you're used to working with the solid modeling tools, a fillet, for example, would be tangent continuous, or maybe you've used the tangent arc, which is also tangent continuous. And an arc in SolidWorks is going to be limited to C1 continuity, whereas a spline can produce C2 or C3 continuity. The next is C2 continuity, so both the splines are tangent as well as their radius will match at this point. So the degree of change in this spline is matched by this spline as well. And lastly, C3 continuity is a raised degree from C2, so we'll get a slightly better match to that curvature. And that's a specific option for a 2-point spline in SolidWorks. You get this option for a raised degree, and this will take it up to a C3 continuity. This is generally easier to see with the curvature combs turned on. So I'll go ahead and highlight all those curves and lines and turn on those curvature combs. So for the top two, these are both just straight lines. This is discontinuous, this is obviously continuous. But this could also be a spline that simply doesn't have any tangent or curvature continuity at the end. So if I change this, for example, to a spline, and show the curvature combs, you can see that there's no matching in the curvature. This curvature overlaps the curvature of the other 2 splines. Whereas you can see the tangent matching here. These share an edge on the comb, but the bounding edge here is discontinuous. Similarly on the other side, this bounding line doesn't continue on to the other side. Alternatively, in the C2 and C3 continuous splines, we can see that this bounding curve progresses down and these match up the curvature. And with a C3 continuous surface or C3 continuous spline, you'll see a slightly better match than what you get out of that C2 continuity. As I stated before, the general goal is to produce a good looking surface. So if we can produce a good looking surface with a C1 continuous spline, there's nothing wrong with that. Similarly, if we wanted to produce it with a C2 or C3, we could do that as well. I just wanted to point out that it's not necessarily the most important thing to increase the level of curvature. As long as we produce a good looking surface, which is our goal, the job is pretty much done at that point. So an example of where a C1 continuous surface is generally enough is when you have two planar surfaces. Typically these two will look exactly the same if this is a C2 continuous surface and this is a C1 continuous surface. I'm going to go ahead and show two sketches here so we can look at curvature combs as well. And for a flat surface, this has zero curvature, so you won't see any curvature combs even if I try to turn this on. And you can see the difference once again is that drop in the bounding curve. And once again, if we wanted, we could raise the degree of the spline. And this is a case where the C3 surface would probably be worse than the C2, as now we have a little bit of a dip in how the curvature changes, and that'll probably produce a slightly worse looking surface than if we just stuck with the standard, which is a bit smoother throughout. A good way to illustrate what's going on here is to use the curvature analysis from the Evaluate toolbar. You can see that the C1 surface maintains the same curvature throughout and changes abruptly at the transition point, whereas the C2 continuous surface matches the radius at this edge and progresses to its sharpest point at the center. Generally, we'll be checking the quality of the surface using two tools, the zebra stripes, to see how these match up. You can see that in the C2 continuous surface, we have the stripe follow into the planar surface, whereas we don't get the same match with the tangent continuous surface. And to analyze these surfaces, we can also take a look at real view graphics and add a high gloss material. In this case, I chose the painted car option and the sienna here, but pretty much any of these would do, or a high gloss plastic. And these surfaces look pretty much the same with regards to reflection, so the two surfaces are pretty much interchangeable. But this won't necessarily be the case with a more complex surface. So you can see we have three surfaces here, the first of which is contact continuous. So once again, if I turn the curvature on, it's actually a little bit more difficult to tell, but if we use the zebra stripes, you can see these don't really match up well on the contact. They're a little bit offset. And you can see how both of the tangent and the curvature continuous match up fairly well. As these are more complex, it's a bit easier to tell the difference with a reflection. In the C0 continuous surface, you can see the edges very easily as you rotate the part. In the tangent continuous, it's a little bit harder to tell, but at certain angles, you can see that edge start to show up, and you have a little bit of a discontinuous reflection here, which won't make for the most attractive surface. And lastly, when we look at the reflections on the C2 continuous surface, it pretty much looks like one flowing surface. When we analyze the surface, we may want to take a look at the curvature combs at different points along the face. And for this, we can use the face curves to produce splines on top of all of these faces. So in this case, I'll just make one face curve across the center, and similarly here, one face curve across the center. And I didn't add any curves to these surfaces as they're straight transitions, so you won't see any curvature. And once again, you can see the difference between the two sets of combs. And we can also move this up and down to analyze this as well. So if I make these a little bit bigger, we can see that this is going to be, once again, the bounding curve is discontinuous on the tangent, while this curvature transitions back in to this surface. And once again, that's just going to make for a better looking surface. So the main takeaways for working with curvature continuity are to generally try to just produce the best looking surface possible. Typically C2 continuity is going to be good enough, and then you can use things like the face curves to make tweaks to the model as well. And in straight transitions, like I showed earlier, generally a tangent continuous surface will look fairly attractive.